evaluate sine and cosine of theta equals 9 pi over 8. Now, 9 pi over 8, that's not in the list of items you're supposed to have memorized for the unit circle, so we're going to need something else. That something else is going to be the half angle formula, but I'm not a big fan of memorizing a lot of formulas, so the way I would do this is just memorize your double angle formula for cosine. So that's how you're going to derive your half angle formula anyway, so you're better off just starting on the ground there. Okay, let's take a look. So we're looking for sine and cosine of 9 pi over 8. 9 pi over 8 is 1/2 9 pi over 4. So what are we going to do? I'm going to follow my nose from the double angle formula, see if I can get a way to go from 9 pi over 8 to 9 pi over 4. So the double angle formula, cosine of 2 theta, equals cosine squared theta minus sine squared theta. Now what we can do here is I can eliminate the sine squared. That's going to give me 2 cosine squared theta minus 1. Or I can eliminate the cosine squared. That gives me 1 minus 2 sine squared theta. If we unravel, so I want to isolate cosine squared and sine squared, I get cosine squared of theta equals 1/2 plus 1/2 cosine 2 theta. So what do you notice here? If I was to let theta be equal to 9 pi over 8, we have cosine squared of 9 pi over 8 equals 1/2 plus 1/2 cosine of 9 pi over 4. And I can definitely get 9 pi over 4. Okay, similarly, we'll get same thing for sine squared of 9 pi over 8. Now, the only drawback is we have to figure out whether sine cosine of 9 pi over 8 is a positive or negative number. When I square, we're going to lose that. But that's not a problem because we can just go to cast. We know what angle we're looking at, so we can figure out the quadrant, and then we can just put our signs in afterwards. Let's see what happens when we put 9 pi eighths into our formulas. So if we put 9 pi over 8 into cosine squared, I get 1/2 plus 1/2 cosine 9 pi over 4. Now, 9 pi over 4 is coterminal with pi over 4. So that's going to mean we have a square root of 2 over 2. That's going to give me 1/2 plus square root of 2 over 4. For sine squared, again, we're using cosine of 9 pi over 4, so it's still square root of 2 over 2. Then we get 1/2 minus square root of 2 over 4. Okay, that means the absolute values of cosine and sine of 9 pi over 8 are going to be square root of 1/2 plus or minus square root of 2 over 4. So we just need to know how to put the signs in. Now, we're looking at 9 pi over 8, so that's going to be pi plus pi over 8. So we're going to be a little bit past pi. So we're down in quadrant 3. That means cosine's negative, sine is negative. Okay, the way you can remember that is you have cast. So if you start in quadrant 4, cast is going to tell you which item is positive of cosine, sine, or tangent. So the thing that's positive is going to be cosine positive, all positive, sine positive, tangent positive. So if we have only tangent positive here, cosine and sine are negative. So my answer is going to wind up being, okay, minus square root minus square root. Okay, we can check our answer. One thing I can do, we can take the sum of the squares, see if we get 1. When we do that, so we'll know we square both of these, we'll get 1/2 plus square root of 2 over 4, 1/2 minus square root of 2 over 4, square root of 2 over 4's cancel, 1/2 plus 1/2 is 1. All right, another check. Let's actually take a look at what these numbers are. So if I push these through my calculator, what comes out for cosine and sine? Remember, they're x and y on the unit circle. My cosine is going to be minus 0.93. My sine is going to be minus 0.38. So if we look at that relative to 5 pi fourths, okay, 5 pi fourths is going to have cosine and sine minus 0.71 minus 0.71. Okay, our point here is going to be a little bit higher than pi fourths. It'll be halfway between angle-wise. So that's definitely in the ballpark. So that's sort of a good check.